See how far we get. All right, this is 3.11, number 45, related rates. A camera is set up at the starting line of a drag race 50 feet from the dragster. So there's the camera. We're told 50 feet. There's the dragster. 2 seconds after the start of the race, the dragster has traveled 100 feet. So 2 seconds later, we're going to draw the dragster. That distance is going to be 100 feet after 2 seconds. T is 2. So it's going to be right there. Then it says the camera is turning at 0.75 radians per second. So this camera is following. First, it's pointing that way. As the dragster moves, the camera rotates, following the dragster. So what's changing? Something is changing at 0.75 radians per second. Well, clearly the angle, hopefully it's clear. Hopefully it's clear that the angle that's changing is that angle, theta. And they tell us that theta changes at a rate of 0.75 radians per second. That's at all time, or at the time at 2 seconds later. So with this, they want the speed of the dragster. Okay, the speed of the dragster. Oh no, I circled the wrong thing with the wrong color. So the gold, the camera's turning at 0.75 radians per second. So that's my gold equation. They want the speed of the dragster. So speed is a change in position, right? So what's changing? This is where you have to use your thought and your brains to figure out what's changing. And hopefully you can see it's this distance is changing. The distance the dragster is from the starting position. So we need to call that something. So what letter would be good for that distance that the dragster has traveled? Some people might do D for dragster, D for distance, R for race. I will do R for the distance it is raced so far. And that's what they want. They want how fast R is changing with time when Y, or R, is 100 feet. Okay, because that's the time they want it. At that point, the point when the dragster is 100 feet down the racetrack. So we need an equation that involves theta and R. Theta and R. Theta, R. This distance is a constant 50 feet. Hopefully you see it, right? Tangent is opposite over adjacent. You see it? So we have the tangent of our angle is the opposite side over the adjacent side. Bam. And in this, we know that theta is a function of time. As time goes on, that angle changes because it follows the car. And we know the distance the car travels changes with time. So both of those are functions. They become box in our chain rule. The derivative of tangent box is secant squared box times the derivative of box. 1 over 50 is a constant, and R is going to be, the derivative of that's going to be dr dt. And they want those specifically when R is 100. All right, this is where it gets a little funky. Secant is 1 over cosine. d theta dt, they gave us 0.75 radians per second. I can handle that. 0.75 radians per second. 1 over 50, I can handle that. dr dt is what we're looking for. I'm okay with that. Okay, I just left with what's cosine? I look back in this triangle. I know that cosine is adjacent over hypotenuse. So now I need to figure out the hypotenuse, but I can figure that out using Pythagorean theorem. The hypotenuse is the square root. Ooh, that color's not good. It's hard to see. Blue should work. Square root of the legs squared. 50 squared plus 100 squared. So cosine will be 50 over that. I can do that. So I'm going to have 1 over 50 over the square root of 50 squared plus 100 squared. And that's squared because it's cosine squared. So that whole thing is squared. Yuck, yuck, yuck. 0.75 radians per second. 1 over 50 dr dt. Okay, I'm almost done here. I don't want this 1 over 50. I'm going to multiply both sides by 50 feet. Those will cancel. Now my answer is on the left, but not quite. Not quite. So I need to flip that. So that's going to be 50 feet, and that's going to be flipped square root of 50 squared plus 100 squared squared over 50 squared times 0.75 radians per second. And that's my dr dt. Okay, I can pop that in my calculator and get an answer. I think I'll do that. Hopefully it comes out right. What do we have here? 50 times 50 squared plus 100 squared times 0.75. Divide that by 50 squared. Whoa! I times it instead of dividing. I get 187.5 feet per second as my answer. Hopefully that's right. Let me see if it's, yes, that is our dragster